to Autism Mathematics. In this video, I'm starting a new series, matrices. Right, so let's start. Matrices. Now, I want us to look at the key points. Right, when we talk of matrix, what does it mean? This is a rectangular array of numbers, symbols, or expressions arranged in rows and columns. Or you can say arrangement of numbers or symbols in rows and columns. So looking at this, we have A, B, C, D. These have been arranged. So this is the horizontal, then the columns are vertical. So the horizontal, we have A, B, C, D. These are the rows, and then the columns are the vertical A, C, B, D. Okay. Now what we want to do is we want to look at matrix in actions. So for example, if you are in a classroom like what we have here, yes, look at how the seats, the chairs are arranged in rectangular form. So this is matrix in action. Let's look at other applications. Now, where do we find matrix in action? In computer science, we have what is called encryption, data security. This is a concept that we use to protect our data. Now, games, especially 3D games, they also use matrices. In economics and business, you can also use matrices. In constructions, they use matrices there. Animation that you see around, they are used to change shapes. Yeah. And then geology. That's the semis geology too. You can use matrix. And dance, a complicated group dance. You can see matrix in action. These are few of them. There are more, but I'm just introduced to few of them. Okay, how do you describe a matrix? A matrix is described by stating the dimension. Now, what is the dimension? Number of rows and then columns. For example, AP is a 1 by 2 matrix. Now, what it means is that we have only one row, but the columns are 2. So you say 1 by 2 matrix. And then if you have AB, so you buy 1 matrix, that is 2 rows and then 1 column. If you have A, B, C, D, then you can say we have 2 rows and then 2 columns. Right. Let's look at this 1, 2, 1, 2. And then the columns are 1, 2, 3. So you can say 2 by 3 matrix. So every matrix is determined by the number of rows and then columns. So an M by N matrix has M rows, that is the horizontal arrangement, and then N columns, the vertical arrangement. Each element of a matrix is denoted by a variable or subscript. For example, if we have A subscript 2, 3, it means that you are in the second row, third column, second row, third column. So always the rows comes first and then column. So that is a further illustration of matrices. That if you have M rows and then N columns, then you're going to have M by N column. So this is called the dimension of a matrix. That is number of rows and then columns. In other aspects, you can say order of matrix. So for example, what is the order of this matrix? So this is 2 by 3 matrix. Right? We have 1, 2 rows and then 3 columns. Let's quickly look at types of matrices. The first one is a square matrix. Now, what is it? A square matrix has the same number of rows and then columns. So you can have 2 by 2, you can have 3 by 3. So a matrix with equal number of rows and columns is a square matrix. The next one is rectangular matrix. As the number of rows is not equal to the number of columns. So 2 by 3 is an example. You can have 3 by 2, 3 by 4, 3 by 4 matrix. You can have 3 by 5 matrix. has unequal number of rows and columns. That makes it rectangular. Then we have zero matrix. Zero matrix is matrix whose entries are all zero or equivalent to zero. So this is what we are talking about. The entries, we have 0, 0. The next one, identity or unit matrix. So this is a square matrix. First, underline the word the square matrix. Yes, having every non-diagonal element equal to 0 and every main diagonal element equal to 1. So this is what is called the main diagonal. You can call it principal diagonal. So when you have a matrix, the principal diagonal is 1, and then all the other entries remain 0. That is unit or identity matrix. Okay. So what the next thing that we want to do is equality of matrix. When do we say two matrices are equal? Two matrices are said to be equal if their corresponding elements or entries are the same or equivalent. Or that is the first thing, they have the same dimension. Right. So look at this one. This is 2 by 2, 2 rows, 2 columns. And this is 2 rows, 2 columns. So then their corresponding entries are the same. A is equal to E, B is equal to F, C is equal to that. So if we have A, B, C, D, then 2, 3, 4. By equality of matrix, A is 2, and then this is B is 3, C is 4, D is 5. Let's apply it in solving question. Given that matrix x2 minus 4y is equal to 3, 2 minus 4y, we have to find the values of x. So this is the entries. Yes. So x is equal to 3, and then this one is equal to that. This is equal to that. So y is equal to 1. Simple as that. Given that 2m minus n is equal to 5, 4, m plus 2 are equal, we have to find mn. So by equality of matrix, you can say 2m minus n is equal to 1. Turning this, so 6 plus m is equal to 5. M will be 5 minus 6. M is equal to minus 1. And then we said that 2m minus n is equal to 1, but m is minus 1. So 2 times minus 1 minus n is equal to 1. We can send this one to this side. So minus 2 minus 1 is equal to n. So n will be minus 3. In other words, you can also compare this and then you solve the two equations simultaneously. Yes. So we are going to have m plus 2n is equal to minus 7, and then 2m minus n is equal to 1. Yes, someone who can use this option. Yeah. Viewers, thank you very much for watching this video. I'm grateful for your time. This is just the introduction. Coming up next will be how to find the determinant of a matrix. So if you like this video and you have not subscribed, just click on the subscribe button, and then you can also turn on the notification button.